All right, hello Algebra 1. So today we are looking at solving multi-step inequalities. So same sort of idea as what we were doing yesterday and the day before, but now we've got more than one step. So for the most part, we're doing the same sort of things that we would be doing if we were solving an equation instead of an inequality. So we're still getting rid of adding with subtracting, we're still getting rid of dividing with multiplying, and vice versa. The only thing you'll want to watch out for is the thing we were looking at yesterday, where if at any point we're multiplying or dividing by a negative number, we need to remember to swap that sign. So the big thing is just remembering that that's still a thing, even though it's not the main thing that we're focused on right now. So that's still a thing we need to remember to do, even though it's not like the main point. So if that were an equal sign there, and we want to solve 2x plus 3 is greater than or equal to 13, if that were an equal sign and we have more than one step, remember we want to get rid of adding or subtracting before multiplying or dividing. So if we have multiple steps, we're getting rid of adding and subtracting first, and then multiplying or dividing. So if we have more than one step, this plus 3 is going away before that multiplying by 2. So adding and subtracting first, then multiplying or dividing. So if we're getting rid of adding 3, hopefully it said subtracting 3. So we're subtracting 3 there, subtracting 3 here. These are gone. And we've got a 2x. We've still got this greater than or equal to there. And then 13 minus 3 is 10. And then if we want to get rid of multiplying by 2, we're dividing by 2. And this time we don't need to flip the sign because we're dividing by a positive number. So that flipping the sign thing is only if we're multiplying or dividing by a negative number. So this time our sign stays and we've got x is greater than or equal to 5. Now, just a heads up that in the interest of not making a 30-minute long math video, we're going to skip the part of this that's graphing. So we did plenty of graphing yesterday and the day before. I think we got the hang of graphing. So these ones you're not going to have to graph, just in the interest of saving time on both of our ends, because it is now 10 o'clock at night. Okay, so this one. Same sort of thing, we're getting rid of adding or subtracting before multiplying or dividing. So we're getting rid of adding 8 by subtracting 8. So we're subtracting 8 here, and we're also subtracting 8 over here. So watch out for when we're subtracting 8. We're subtracting it from both sides of our inequality, just like we would be doing if there was an equal sign there. So we're subtracting it here and over here, but we're not subtracting it from that 3x, because that 3x has an x with it. So these are gone. We've got a negative 3x. And then over here we have a negative 4 minus 8, which gives you a negative 12. All right, now if we want to get rid of multiplying by a negative 3 or dividing by a negative 3. And since we're dividing by a negative, we need to remember to, hopefully it said swap the sign. So we've got an x here. We're switching this from a less than or equal to a greater than or equal to. And negative 12 divided by a negative 3 gets you a positive 4. And there we go. Yay. Okay, one thing to watch out for these is if you got something like this, because it looks like we should be getting rid of subtracting with adding, but the subtracting actually goes with that negative, with that 3x there. So that's a 7, and then minus goes with the 3x. So if it helps, maybe think of that as a plus a negative 3x there. So that makes it a little bit easier to see, okay, we're getting rid of adding 7 by subtracting 7. And we're subtracting 7. These are gone. Now we got that negative 3x, so we just need to not lose that negative or that minus that's hanging out in front of that x there. And 15 minus 7 is 8. Okay, and now we're going to divide by that negative 3. And if we're dividing by a negative, we need to remember to swap the sign. So instead of a less than, we get a greater than. And if your fraction isn't going to give you a particularly nice decimal, so that'd be negative 2.3 repeating, feel free to leave that as a negative 8/3 instead. If you really, really, really like decimals and really, really, really want to call it this instead, I mean, this is fine. But this is also okay. So if you turned it into this, that's fine. If you left it as a fraction, that's also perfectly fine. We just want to make sure that that's negative and that we swapped our sign. Okay, now, if we got something like this, where we have some variables on both sides of our equal sign, we want to get rid of one of those sets of variables. In general, it's nice to get rid of the smaller one, because that way we don't have to deal with negatives. So it's nice not to have to deal with that whole swap sign if you divide by a negative thing, and we can avoid that if we just don't have negatives in the first place. So if we subtract this 3x here, then we don't have a negative in front of our variable to deal with. So these are gone. 5x minus 3x is 2x. And we've still got this greater than or equal to. And watch out for that's a negative 11. So when you're crossing these off, don't lose that negative that's hanging out in front of your 11. And again, if it helps, maybe think of that as a plus a negative 11. That makes it a little bit easier to tell we're subtracting that to get rid of adding. And also a little bit less likely that you'll lose that negative. All right, now we're down to getting rid of adding before getting rid of multiplying. So we're subtracting a 3 to get rid of adding a 3. And we've got a 2x. And then over here, negative 11 minus 3 gets you a negative 14. Now, when we're dividing by that 2, do we flip that sign? There's a negative here, but we didn't divide by it. So we're only flipping our sign if the thing that we divided by is a negative. So this one wasn't. There's a negative in our problem, but it's over here and we're not dividing both sides by that thing. So this is a negative 7. This sign stays, and we've got our x over here. And there we go. Okay. All right, same sort of thing here. So if we want to get our variables over to the same side, we can either subtract the 12m or we can subtract the 3m. Again, it's going to be nicer to go with the smaller one. That way we don't end up with negatives, but you can technically do it either way. So we're going to subtract this 3m. Subtract this 3m. Well, these are gone. 12m minus 3m is 9m. And then we got that 18 still hanging out over here. And then we're going to get rid of subtracting 9 by adding 9. Adding 9. These are gone. We got a 9m. 18 plus 9 is 27. And now we're dividing by 9. So aside from that dividing by a negative thing, we're doing exactly the same thing we would be doing if that was an equal sign there. So when we were solving these equations a couple of chapters ago, this is exactly the same thing, with that one exception of if we multiply or divide by a negative, we need to remember to swap that sign. But other than that, your steps are exactly the same. And then 27 divided by 9 gets you 3. And there we go. Now, couple weird things that can happen with these. And the first one is if we got something like this. So if we have a number outside of our parentheses, we need to remember to do what? Hopefully you said we need to remember to distribute that number. So when we're distributing, we're multiplying by whatever's numbers on the outside of our parentheses. So 4 times 3 gets you 12. 4 times 7 is 28. That minus is still a minus. And over here, 6 times 2 also gets you 12. And 6 times 8 is 48. So if we try to do what we did in the last one and get rid of one of our variables by subtracting it, if we subtract that 12x here, and we subtract the 12x here, these are gone, so are these. So now we've got a negative 28 is greater than or equal to 48. So if all of our variables are gone, then we can't really find x, so we're just looking for is what we have left true. So is negative 28 greater than or equal to 48? No, because a negative is not going to be bigger than a positive. So if all of our variables are gone and we've got something that's never true, that's one of these. That's no solution. So that happens if all of our variables are gone. So if all of our variables cancel out and we ended up with something false. So if all of our variables are gone and we have something false, then it's one of these. It's no solution. No number that we plug in here would work. The other thing is if we've got something like this, where if we distribute that 3 there, we've got a 6x. 3 times 5 gets you 15. And this time if our variables cancel out, because they're going to cancel out when we subtract that 6x there. These are gone, those are gone, but this time we have something that's true. Because 15 is always going to be bigger than negative 2. Your positive is always going to be bigger than your negative. 15 is bigger than negative 2. So if all of our variables are gone and we've got something that's always true, then we're going to call that all real numbers. Now, up until now, we've been pretty much using that and this interchangeably. So all real numbers, infinite solutions. The reason we want this one here is because technically all of these have an infinite number of solutions. So if I'm saying we are everything greater than or equal to 5, there's an infinite number of things that are greater than or equal to 5. So that's why we don't want to say that here. So there are some situations where we could use either this or this. This isn't one of them. So this is a situation where you definitely want to use this one, not this one. Don't use this. Don't use that. So all real numbers, not infinite solutions. Okay, so those are the two kind of oddball things that could happen. So if all of your variables are gone and you have something that's always true, then it's one of these. So importantly, those two things only happen if all of our variables cancel it out. So once those two are a thing, everyone wants to use it everywhere. That's only if all of your variables are gone. So that only happens if your variables cancel out and all you have left are numbers. If you have something that's true, it's this. If you have something that's false, it's no solution. Okay, last thing we're looking at is a little bit of some word problems. They're back. So if we have 2/5 of a number increased by 7 is at least 3, we're going to take this apart bit by bit. So if we have 2/5 of a number, that's 2/5 times whatever your favorite variable is. So I'm going to call that 2/5 x, because my favorite variable is boring. And then if we're increasing it by 7, increasing means we're adding 7. So we're going to add 7. And then is at least. At least is one of these again. So if that's not a thing you already jotted down somewhere, at least is one of these. Because if we want to be at least 3, we want things that are bigger than 3 and things that are equal to 3. So like 5 is at least 3, 12 is at least 3. So that's things that are 3 and things that are bigger than 3. And now we're just going to solve that. So we're going to subtract 7, get rid of adding 7. These are gone. We got 2/5 x. 3 minus 7 is a negative 4. And if you've got a fraction, you could either turn that into a decimal, and that one's going to be a pretty nice decimal, or the other thing you could do is multiply by your reciprocal. So if you turn it into a decimal and divide it by 0.4, that's fine. If you turn that into 5/2 and multiply by that, that's also fine. So these are gone, those are gone. We've got negative 4 times 5/2. 4 times 5 is 20. 20 divided by 2 is 10. That's negative. But we didn't divide or multiply by that negative, so that sign stays. So this stays a greater than or equal to, because even though this was a negative, the thing that we multiplied both sides of our inequality by wasn't. All right. One more of those. So we got 3 less than a half a number is more than 5. So if we're looking at where our number is, we got half a number. So half a number, you could either call that 1/2 times whatever your variable you like. And then 3 less than that, again, watch out for that's this, not this. So if we have half a number and we have 3 less than that, we're subtracting 3 from that number. And then we want that to be more than, so is more than 5. Okay. And then we're adding 3 to get rid of subtracting 3. So once we've got it set up, we're solving it just like we did the other ones. And 5 plus 3 is 8. And if we want to get rid of that 1/2, we could either divide by 0.5 if you turn that into a decimal, or we could take that times 2. You'll get the same thing either way. These are gone. 8 times 2 is 16, and there weren't any negatives involved, so we're not going to swap that sign. Right. And there we go. That is multi-step inequalities. The numbers for the homework are in the description below. They're also up on Google Classroom. So once you're done with that, either screenshot that, take a picture of that, and send me an email of that so that you don't have to wait until we're back in school to hand me that piece of paper. So just go ahead and take a picture, email me that, and we'll call that good. And I will see you next week.